Hello, welcome to the video. This is video 29 on kind of water use in the United States and what we put our water towards. You can see from the pie chart here, we get a lot of precipitation every day. Close to 16 trillion liters fall on the continental United States on a daily basis. The problem with it is a lot of this is lost and not really maximized by our current systems. So we're going to lose 31% of it to runoff. That's landing on concrete or landing on ground faster than it can absorb, and it runs into streams and to lakes and eventually the oceans and disappears forever. The other big portion of this, 66% of it, is going to be lost due to evaporation or transpiration. So that could be surface waters that are potentially useful, but evaporate before we can take advantage of them. But it's definitely not making it underground. And so our main source of water is that underground aquifer water. The main reason why we like it so much is as it filters through the layers of the soil, that is going to take out a lot of those pollutants, the dirt, the grime. A lot of things are going to be drawn out from the soil. The plant roots will take out some of the nitrates and phosphates like we talked about with water quality. And so it's very clean supply of water down there, but it takes a long time to recharge. And so 3% is a very small amount of water. And so a lot of our problems come from overuse on aquifers or degrading the aquifers in some way. So we'll see a couple different examples of that through the video. This is kind of how we use the water. The numbers on the map here denote the consumption divided by the renewable supply. And you can see that there are some very stressed areas. Stressed meaning not having the resources to support the way of life there. The big area here is the Southwest. The state of Arizona is using up more water than what is in the renewable supply. And so if we exceed the renewable amounts, that's unsustainable. Over here in Florida and Georgia, you can see that we have a very high amount of water and it's used at a much lower rate per the region. Some people might wonder why the consumption in Arizona is higher than the consumption in Georgia, because we know we grow a lot of crops in Georgia, and while they do grow crops in Arizona, not to the extent, one of the big reasons here is the climate over here is very humid, and so our evaporation rates are much lower, whereas in Arizona it's very dry heat, and so evaporation is very high and it draws on it. So you can see some other areas that have some high consumption. Out here in the Midwest, we do a lot of our farming here, so that consumption is really high, not due to population numbers, but due to agricultural use. Same thing is true for California. It's a really high number there. You've got the coupling of high agriculture with dry climate, creating a big draw on water up there. And so there are some regions that are very water stressed, and we've got regions where we are kind of water rich. And that's one of the big problems with water is the distribution. Do we have it where the people need it? Mono Lake is the first case study we're going to talk about here. Mono Lake is a lake in California. And so all the water to Mono Lake comes in via some rivers, and the only way the water leaves is by evaporation. So this is a very similar scenario to the Aral Sea. And what happened was as Los Angeles was growing and developing, they diverted a lot of the water from the rivers entering Mono Lake to the city of Los Angeles. And when you cut the inflow, the only thing that was happening then was evaporation at the lake. And so when it evaporated, we got a really high salinity content. A lot of salt was left behind, and that affected a lot of the animals that lived there. And so it had a very unique ecosystem of brine shrimp and alkali flies. The predators refers to some birds, seasonal birds that would migrate in and feed on these when they were really blooming in population. But with salinity up and water down, these organisms aren't as successful or aren't as viable, and so they started to die out and the birds stopped coming to the lake. This is not the case with Aral Sea though, because in the United States we actually kind of are focused on this. We have a clear pattern of ownership. It belongs to the United States, and so we're going to do what we can to reclaim it and restore it. And so in 1989 those processes began. A lot of the restoration comes from sending reclaimed water back, and so we're diverting a little bit less, but we're also created another inflow. And so this would be like water that lands on the concrete in the city of Los Angeles. Some of that gets sent back to Mono Lake, and that can help reduce the salinity because the more water we add, the less the salt concentration becomes. Another really important example for water use in the United States is the Colorado River Basin, and this is a picture of that watershed. The Colorado River runs from anywhere in Wyoming to Colorado all the way down into the Gulf of California, which is in Mexico. It's down here at that kind of Baja, Mexico down there. There are two regions to this, and so you have an upper region and a lower region, and this is kind of a big fight over who owns the water, because there's a lot of people that live in this area. There's not a lot of water out in the Southwest, and so we need to figure out a way to divide them up. The major issue here is that we divided it up in 1922, and that was great for the time being, but we had some problems in the upper region in Colorado, Utah, and Wyoming. In 1922, they were very sparse population, not a lot of people there, and so their demand on the water was very small. And so when we allotted it in 1992, we gave a larger amount of the water to the south end, to the downstream people down in California and Arizona. And so it's kind of unequally shared. And so the lower region, they grew over accustomed to using more water, and they kind of developed industry and built towns and people and stuff like that. And so you have this unequal usage or unequal allotment. And now that we've got more people living in the upper region, it's creating this strain or the pressure on the lower region, because if we withdraw too much early, before the water gets to them, there's nothing left behind. And this is especially the case down in Mexico, where the water does not reach anymore. It's just a bare trickle down there. And so some of the some of the alternatives here, the way we can fix that is by creating a desalting plant or desalinization plant in Arizona. What that would allow us to do would be taking seawater and boiling the seawater to remove the salt and creating fresh drinkable water. And so the idea is, if we created desalinization plants, those plants could provide water for Arizona, which would allow us to let more of that river run down through and into Mexico and eventually into the ocean. It would restore some of the wetlands that are occurring down here that are currently drying up because they're not getting the supply of water. And it would solve a lot of issues with the Colorado River Basin. It's essentially, we've got one big major river here, and we've got too many people drawing water from it, which creates all the big problems. Another big issue with water use is aquifer depletion, and there are three big reasons where this is a major issue. The one that I want to kind of highlight is the high plains. This is where we grow a lot of food out here, and so that food requires irrigation water, which all comes via the aquifers. And this can lead to a couple problems, like subsidence is very common out here, where the whole regions of land are sinking lower and lower and lower. As we deplete the water, that upward hydrostatic pressure reduces, and so the ground sinks down. It can also lead to sinkholes and saltwater intrusion if you're talking about regions of the coast over here in California, where you can draw so much water out of the aquifer that it draws in the ocean water. The Ogallala Aquifer is the largest aquifer in the United States, and you can see the aquifer ranges from Nebraska all the way down to Texas. This aquifer is heavily relied on for crops, and so you can see the crops that are being grown out here in the aquifer. The reason why they're circular is there is a central well and a pump that draws water up from the aquifer. This long arm here is a sprinkler arm, and what happens when we turn it on, it'll rotate around and water the plants in the circle. And so it's a very efficient way, or very effective way, to irrigate the crops, because it's kind of autonomous. It can run on its own. Notice these are very large things, 100 acres for this one circle of crops here. The real issue with the Ogallala Aquifer is that we are drawing water out much faster than it can be replaced. And so we are, here's the number, 40 times faster. So we're heavily depleting this. And we also really rely on it. And so if it dries up and you no longer have access to that water and you're a farmer, that is going to give you a big issue and potentially force you out of work and have to move on and find a place that would have the water to support it. Some ways that we can prevent that from happening or to save the Ogala Aquifer are water conservation. So this would be using less at home, using less on the farms, maybe trying dry land farming where we're growing more native species that require less water inputs and irrigation. Another good way is through more efficient irrigation. And so they have a couple different technologies that have developed. One of them is a drip irrigation. And so if we've got a plant growing, the drip irrigation would be a hose across the ground, so we can't lose any due to evaporation because it's a hose. And it would have a really tiny sprinkler head right above the root of the plant. And it would literally drip water directly onto the roots. And so every drop of water in this type of system is going straight to growing the crops. Compare that to those large sprinkler arms in the last picture that sit up above the plants and essentially shower them in water. This is a much more efficient way to water the crops. And so this could really reduce the strain on the Ogala Aquifer, and it could also allow it to kind of recharge. And so that would be a good thing in the grand scheme of things because we'd help replenish that. So those are the big United States water issues that I'd like to talk about. Thank you for watching the video. Please bring notes and some sort of evidence and be ready to discuss the video tomorrow. Thank you.